For the division problem of 2,498 divided by 4, using the place value diagram, I would set up my original problem, 2,498, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the 90. And then the 8 is here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 ones. And in order to divide it by 4, then basically what you're doing in a place value about is creating similar to what you have in basic addition and subtraction. You have you're creating an array, so you want to take this amount and you want to break it up into 4 groups. So I can't take 2 thousands and break it up into 4 groups of 1,000. So what I'm gonna do is exchange each of the thousands for 1,000 cards to equal the same amount of value. So I'm gonna take 2,000 and I'm gonna exchange those into hundreds. So you're gonna have 20 more cards to make 2,000. 20 times 10 is 2,000. So I have my original 4. I'm just gonna move this up so you can see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the original 4. And then I also need 10 more. So again, I'm just gonna move this up so you can see it. And I'll count with my fingers so you can see all the ones I'm using. 3, 4, 5, 6, 7, 8, 9, 10. So total, it looks like a lot of cards, but when you count it out, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 1,000 here. And then 100, 200, 300, 400, 500, 600, 700, 800, 900. And that's another 10. So that's another 1,000. That's 2,400. So this is the same amount as having 2,000 here. But this way I can divide it up into 4 columns to break it down. So I'm going to stack these up so that I can break them down into the groups. So the best way that I know how is just doing it until it comes out evenly. So I'm gonna move these over just so you can see, but they belong in the hundreds column. I'm gonna keep them on the line so you don't get confused. I wouldn't confuse a child. So I'm bringing this down to 4. So there's 1. So basically I'm gonna take my pile of all the ones I had and I'm gonna keep separating it down into the 4 groups until I either have an extra or I come out even. So I have to use everything I had there because that was the total. So this is gonna break down evenly. I'm not gonna have any remainders. So in my each group of mine, I'm gonna have 1, 2, 3, 4, 5, 6, and then I have 6 here, and 6 here, and 6 here, and 6 on the bottom. So each group, let me separate this a little bit more so you can see that, has 6 groups of hundreds. Because if you look at the problem, 4 goes into 24 6 times. And that leaves me 98. So that leaves the 98 that I need to break down. So I'm going to move these over. I already separated them. I know that they're 600 each. And then I have the 98. So again, I'm going to do it in groups of 4. So in this case, when you do it, you have a group of 2 in each section, and you have 1 remainder. So I'm going to exchange this for 10 units, so I can break those down. So I'm going to add 10 more ones to this area, the 1 unit, or the ones column, or singles. So now I have the 1, 2, 3, 4, 5, 6, 7, 8 that I started with, plus my 3, 4, 5, 6, 7, 8, 9, 10. The 10 units that I added because I exchanged one of these for 10 single units. So now I'm going to do the same exact thing with this column. I'm going to take all these, kind of move them over, and break them on down into 4. 1, 2, 3, 4. And I'm going to do the same thing all the way until I either have none left over or I have a remainder, and that would give me my remainder. It's stuck on my counter, sorry. And so you see that I have a group of 4 each, and then I have a remainder of 2. So the remainder of 2 over 4, it's actually a half. It's the same, 2/4 is the same, is equal to 1/2. So I have a remainder of 2, or a half. So my total, or my quotient in division, because it's the dividend by the divisor and the quotient is the answer. So you would have, I would have 1, 2, can't see all those. 1, 2, 3, 4, 5, 600 and 2 tens, so 20, and then 1, 2, 3, 4. So you'd have 624 with a remainder of 2/4 or a half. Now the other way you can do this problem is by the scaffolding method. So the way that you would do that is you turn a division problem into an addition problem instead of just a subtraction. So you would take this and divide it into these amounts and subtract it off. But what you're doing is you're adding the totals that you get to the answer. So you're building on your totals to get to the answer. So we know that 4 goes into 2,500 times. So that leaves 498. And then 4 goes into 498. 124 times. That's 496 with the remainder of the 2. And then what you would do is you would add these two amounts and you would get 624, and then you have your 2/4. So this would equal 624 and a half, or it would be written with a decimal as 0.5. I think the benefits of using the place value cards is that it's a visual way and a kinesthetic way to visually see how the problem's broken down into the groups, and it makes it less confusing. This way, for a child that maybe has a better strength in math and using the numbers versus place cards, can do it this way. And it's less steps and less movement of all the extra of having to exchange and move things around. This way would be a benefit. I prefer the place card way. Again, I like visual ways. I think that kids seeing a visual and being able to move pieces around and group them is a better way of understanding how to break down a problem, especially when it comes to math. So I would definitely choose this way when I'm teaching younger students.